That's right. I'm going to show you the most easiest solution for the integral of cube root of tan x on the entire YouTube. So make sure you watch this video till the end. In order to integrate cube root of tan x, what we'll have to do is first get rid of that cube root. And in order to get rid of that cube root, what we'll have to do, the easiest thing we can do is put tan x is equal to u cube. The moment you do that substitution, that cube and that cube root will cancel each other out. Now let's convert that entire integral from the x world to the u world. In order to convert that integral from the x world to the u world, we'll also have to find the value of dx. In order to find the value of dx, first let's find the value of x. So from here you can say that x is nothing but tan inverse of u cube if you shift that tan on the right hand side. Now let's differentiate both the sides with respect to x. So from here you can say that therefore dx is equal to, now differentiation of tan inverse of u cube is 1 over 1 plus u cube square times the differentiation of u cube is 3u square times du. We use the chain rule here. We know that differentiation of tan inverse of x is nothing but 1 over 1 plus x square. Since it is u cube, it is 1 over 1 plus u cube square times the differentiation of u cube, which is 3u square. Okay, let's simplify this a little bit. So we have 1 over 1 plus u to the power 6 by applying the law of exponents here, and in the numerator we have 3u square du, and that's nothing but the value of dx that we get from here. Now let's make that substitution and convert that entire integral now from the x world to the u world. So that integral is going to look like integral of cube root of, I have u cube inside, and instead of dx I can write 1 over 1 plus u to the power 6 3u square du. That cube root and cube will cancel each other out, and you will have integral of u times 3u square times 1 is 3u square divided by 1 plus u to the power 6, and obviously you are integrating now with respect to u. Now what you can do is that 3's constant can be taken out of the integral. So you have 3 times integral of u times u square is u cube, but let me just write it as u square times u anyway, divide by 1 plus the denominator u to the power 6. Let me write it as u square to the power 3 with respect to u. The reason I'm doing that is, if you notice, this much part of the entire integral is now function of u square. Now since it is a function of u square and there is already a linear term present here, if you end up putting u square is equal to some substitution, let's say if you put u square is equal to t, the differentiation of u square, which is 2u, the linear term, is present right here. So that will actually help us in simplifying. So what we'll do is we'll put u square is equal to, let's say, t. So if we put u square is equal to t, now let's again differentiate both the sides with respect to x in order to convert that du now in terms of dt. So differentiation of u square is 2u du is equal to dt. Now if you notice here, we need u times du. Okay, so from here we can say that u times du is nothing but dt divided by 2, and that's the value of u times du. So now if you convert that integral from the u world to the t world, you will have t divided by 1 plus t cube, because u square is nothing but t. So we have 3 times integral of t divided by 1 plus t cube, and that du here is nothing but now, or sorry, u du is nothing but dt divided by 2. So we were able to convert that entire integral now from the u world to the t world. Notice that I have written that this u du as dt divided by 2. Okay, so now let's simplify this. If you notice now carefully, this is a polynomial divided by polynomial type of integral. Okay, now whenever you see a polynomial type of polynomial, chances are it is a partial fractions if the power of numerator is less than the power of denominator, which is true in this case. Let's see if we can factorize that denominator to be able to apply the partial fractions here. Okay, first of all, this 2 can be taken out of the integral because it is a constant value. Integral of t divided by, now this 1 plus t cube can be written as 1 cube plus t cube, and we know the factorization formula of a cube plus b cube is nothing but a plus b, a square minus ab plus b square. So we can actually apply that formula over here, and we get 1 plus t 1 minus t plus t square. By applying that factorization formula, I was able to factorize that denominator. Now, once you factorize that denominator, you can apply partial fractions here in order to simplify this. Now, in order to apply partial fractions here, we'll say let t divided by 1 plus t times 1 minus t plus t square be equal to a divided by the first factor. So a divided by the linear factor, which is 1 plus t. Notice that the second factor here is a quadratic factor. Whenever you see the quadratic factor in the denominator, the numerator term is a linear term. So it is bt plus c. Notice that the variable is not x here, it is t here. So whenever the denominator is quadratic, the numerator is a linear term in partial fractions. And whenever the denominator is a linear term, the numerator is a constant value. Now let's try to simplify this and let's see what do we get. So we have, we can just cross multiply here and we have a times 1 minus t plus t square plus bt plus c. You can multiply this and this times 1 plus t divide by, you have 1 plus t times 1 minus t plus t square. And on the left hand side, you have t divided by 1 plus t times 1 minus t plus t square. Okay, that's what you have. Notice that this term and this term on left hand side and right hand side will get cancelled. And what you have really is t equals a times 1 minus t plus t square plus bt plus c times 1 plus t. Okay, now in order to find the values of a, b and c, what most people on YouTube or teachers will do is they will just multiply this entire expressions and compare left hand side and right hand side. It is not incorrect, but there is an extremely inefficient way to do that. What I like to do is substitute some random values of t that will make your calculation simpler. So for example, if I put t is equal to minus 1, what will happen is this entire expression will become 0. Okay, and you will end up getting the value of a. So let's start by putting t equals minus 1. So if you put t equals minus 1, what you get? Just substitute minus 1. So minus 1 equals a times 1 minus minus 1 plus minus 1 square plus, notice that if you put minus 1 over here, this entire thing is just going to become 0. Okay, so therefore you have minus 1 is equal to, so this is 1 plus 1 2 and this is also 1, so 2 plus 1 3, so you'll get 3a. So immediately you will end up getting a is equal to minus 1 by 3. So that's the value of a that we get. How simple that was when you were able to substitute the right value of t. Now let us substitute some other value of t. Let us say now, to make it easy, just put t is equal to 0. Let's now put just t is equal to 0. I think that's the easiest value that I can think of. So if you put t is equal to 0, let's see what do we get. So substitute 0 on left hand side and right hand side. Notice that we also know the value of a now. So you can say 0 is equal to minus 1 by 3, which is the value of a here. 1, this is 0 and 0, so you can just leave it. Plus, also this is, since t is 0, this will become 0, and you will get c times 1 plus 0 is nothing but 1. So therefore, if you just simplify this, you will get the value of c is equal to 1 by 3. How easily we were just able to get the values of a and c from here. Okay, now the only value that is left is the value of b. You can really substitute now any value of t that you want. Let us substitute t is equal to 1 now. Now let's simplify this. So you have 1 is equal to, now 1 minus 1 is 0, 0 plus 1 is 1, and minus 1 by 3 times 1 is minus 1 by 3 plus, and this 1 plus 1 is 2, so you have b plus 1 by 3 times 2. Okay, so this minus 1 by 3, when you take it on left hand side, it will become 1 plus 1 by 3, which is 4 by 3, is equal to b plus 1 by 3 times 2. Okay, this 2 and 4 can become just 2 over here. So now you can see that this 2 by 3 is equal to b plus 1 by 3, which implies that b is nothing but 1 by 3. 2 by 3 minus 1 by 3. So that's the value of b that we were able to generate. Now that you have found the values of a, b, and c, what you can do is you can actually replace this function inside of the integral with actually this function by substituting the values of a, b, and c. Let's see what do we get. Now let's see how do you simplify this resulting integral that you get. So you have 3 by 2. We can actually give that integral to both of those terms now. So you have, let's put a bracket, integral of minus 1 by 3 divided by t plus 1 dt, okay, plus integral of 1 by 3 you can factor out. So 1 by 3, again you'll get t plus 1 divided by t square minus t plus 1 dt, and let's close that bracket. Okay, you can now integrate those separately. So you get 3 by 2. This minus 1 by 3 is constant, can be taken out of the integral. So you have minus 1 by 3 integral of 1 over t plus 1 dt, plus also this 1 by 3 is constant, can be taken out of the integral. So you have 1 by 3 integral of t plus 1 divided by t square minus t plus 1 with respect to t. Now the first one is very easy to integrate. We'll look at how to integrate this second part. First of all, let's factor out this 1 by 3 from this entire both of those integrals. So you have 3 by 2 times 1 by 3. Inside of the bracket you have minus integral of 1 over t plus 1 is ln mod t plus 1, okay, plus you have integral of, now remember, whenever you want to integrate a linear term divided by a quadratic expression, a linear expression divided by quadratic expression, what you have to do, you have to try to adjust the differentiation of this quadratic term in the numerator. Now differentiation of this is nothing but 2t minus 1. Okay, now this t is already present, you just need that 2 here, okay, in order to have that differentiation. So what you can do is actually multiply and divide by 2. So I have 1 by 2 here, so I divide by 2 and then I multiply by 2. So I have 2t plus 2 divided by t square minus t plus 1. I hope that made sense, and this is with respect to t. Now you need a minus 1 here because the differentiation is 2t minus 1. So you can write actually that plus 2 as minus 1 plus 3 because we need that minus 1. So let's see how do you do all of that. This 3 and this 3 will get cancelled. So you have 1 by 2 minus ln mod t plus 1 plus 1 by 2 integral of 2t. Remember, I'm writing that plus 2 as minus 1 plus 3. Why I'm writing it? Because I know the differentiation is going to generate here minus 1. So 2t minus 1 is the differentiation. So since I need that minus 1, the only way I can get it is I can write that plus 2 as minus 1 plus 3 divide by t square minus t plus 1 with respect to t. I hope that made sense to you. Now that we have a differentiation of this quadratic term here. Okay. Now in order to simplify this, what we can do is we can actually split that quadratic in both of those terms. And let's see what do we get. So we have 1 by 2, open the bracket, minus ln mod t plus 1 plus 1 by 2, and you have integral of inside of that integral, just split that quadratic term in both of those terms. So you have 2t minus 1 divided by t square minus t plus 1 plus 3 divided by t square minus t plus 1 with respect to t, and let's close this box bracket. Now the integral of the first term here, 2t minus 1 divided by t square minus t plus 1, notice that this is of the form f dash of x divided by fx. Okay, whenever you have the integral or function of the form differentiation divide by the actual function, the integral of this is nothing but log mod function. Okay, so the integral of this portion is nothing but log of t square minus t plus 1. Okay, we'll still have to figure out this second part of the integral. We'll have to do completing square here. Okay, let's see how will we do that. So we have 1 by 2 bracket minus ln mod t plus 1 plus 1 by 2. Okay, let's put a bracket. Now the first integral, as we discussed, it is ln mod t square minus t plus 1, okay, plus 3 times. This 3 is constant, can be taken out of integral. In order to integrate this part, we'll have to do completing square method. So let's see how do you do that. In completing square method, first we have to make sure the coefficient of t square is 1. Then what we have to do is the coefficient of t, the linear term, we have to divide that by 2 and then square it. Okay, so this minus 1 by 2, so minus 1 was the coefficient of t, you divide by 2 and then square it, so you get 1 by 4. So we can add 1 by 4 and subtract 1 by 4 in order to do completing square. So let's simplify this. So we have 1 by 2, everything else I can just write the way it is, ln mod t plus 1 plus half bracket ln mod t square minus t plus 1 plus 3 times integral of 1 divided by t square, in the numerator actually have dt, so t square minus t, let's actually add 1 by 4 and we have plus 1 and we can subtract 1 by 4 here. Okay, and then we can close the round bracket and then we can close the box bracket. I hope that made sense. Now this first portion, t square minus t plus 1 by 4, this is nothing but t minus half the whole square. Okay, and this 1 minus 1 by 4 is nothing but 3 by 4. Okay, so your whole thing will become, you have, let me just make some space here. So we have half minus ln mod t plus 1 plus half ln mod t square minus t plus 1, okay, plus 3, note that there is a round bracket here. Okay, so plus 3 integral of dt divided by, okay, t minus half the whole square plus this 3 by 4 can be just written as root 3 by 2 the whole square. Okay, and let's close that round bracket and close that box bracket. Now it's very easy to integrate because we know the integral of 1 over t square plus a square. We know that integral of 1 over x square plus a square dx is nothing but tan inverse of x by a. Okay, so we can actually do that, use that integral formula, and we have half minus ln mod t plus 1 plus half bracket ln mod t square minus t plus 1 plus 3, and instead of this integral I can write tan inverse of t minus half divided by root 3 by 2. Let's close the box round bracket and then close the box bracket. Let's add the constant of integration c, and this is nothing but the final result, but remember we'll have to convert it back to the x world, and in order to do that, remember that t was nothing but u square. So now you can, instead of t, write u square. Also you can multiply these constant values inside to simplify it further. So you have minus half ln mod, so this half times minus is minus half u square plus 1, this half times half is plus 1 by 4 ln mod u square square is u to the power 4 minus u square plus 1, and remember that that 1 by 4 will also get multiplied with this 3, so you have plus 3 by 4 tan inverse of u square minus half divided by root 3 by 2 and plus the constant of integration c. Remember that we'll still have to convert it in the x world. We converted it from the t world to the u world. Now we'll have to convert it from the u world to the x world, which was the original function. And for that, you'll have to remember that tan x was nothing but u cube, which would imply that u was nothing but cube root of tan x. Okay, so instead of u, now you can write cube root of tan x. So you can, let's see what do we get. So we have minus half ln mod cube root of tan x is nothing but tan x to the power 1 by 3. Okay, now then there is a square, so tan x to the power 1 by 3, and then there is that square. Okay, so that will actually become 2 by 3. Okay, so tan x to the power 2 by 3 plus 1, okay, plus 1 by 4 ln mod, remember tan x to the power 1 by 3, so this will become tan x to the power 4 by 3 minus tan x to the power 2 by 3 plus 1, and plus this last term will become 3 by 4 tan inverse of u square. So instead of u, you can write cube root of tan x. So you have tan x to the power 2 by 3 minus 1 divided by root 3 by 2. Let's close the bracket, plus constant of integration c, and this is nothing but the final result of the integral of cube root of tan x. If you want to see more such efficient and conceptual math and calculus hacks, you must hit that subscribe button. I hope you like this video. I'll see you tomorrow. I do post math and calculus content every single day. Hit that subscribe button. I'll see you tomorrow.